If you've seen any of my previous demonstrations on projection types, you'll be aware that so far it's been limited to projecting onto a single piece of geometry. What I want to do in this short video is demonstrate the setup workflow for projecting textures onto multiple pieces of geometry. I also want to briefly discuss some of the associated benefits and drawbacks that I've found arising from this methodology. So you can see I've got a script open here. It's basically the script that I used. If you've seen any of my previous videos, then it's the script that I used to create the basic setup. There are a couple of things that I've changed. I've added a couple of pieces of geometry in here, so I've got a card and a sphere because I'm going to be projecting onto two pieces. I've replaced the original checkerboard with my custom node. What else have I got? And over here I've actually got two new nodes which I'm going to need later on for combining the two pieces of geometry, but I'll come back to that later on. Okay, so I'm going to start. And one more thing is that I've also made a slight change to the shot camera. I'm just going to bring this around to slightly more orthographic view, more of a top-down view, and you can see that what I've done is that I've replaced the sort of the pushing and pulling camera movement, which I started off with this sort of slight lateral movement. So the camera's moving at an angle. I'm actually going to put some geometry into this space, so what this is going to do is it's going to kind of reveal one piece of geometry from behind the other. So there's a little bit of sort of diagonal translation there, and also a tiny bit of rotation just for framing purposes. Okay, so I'll just flip that back into more of a perspective view, and I'm now going to create a projection. So as before, I just need to get all those nodes and copy them. I'll just come over here and paste them into this area. I'm also going to get my scanline renderer and my merge material, paste these down here, and I'm going to set up a basic projection. So my shot camera goes into my scanline renderer. I'm just going to start with the sphere, and I'm going to project into the sphere from this camera. In fact, I won't connect up the camera, but I'm going to project this grey texture into it. I'll leave these for now. I won't actually use the projection camera, I'm going to generate one. Okay, so we don't see anything particularly dramatic here because we don't have a projection camera, so this is just being just going straight flat onto the UVs of the sphere. Okay, so let's take a look. I'll have a projection somewhere near the front. Let's go with frame 5. Because that's obviously revealing a little bit of the side. So as before, copy the shot camera, rename it a projection camera, and I'll just append it with number 5 for the frame that I've generated it from. Right click and choose no animation on all knobs to kill the animation, but retain the transformation properties from frame 5, and then finally just give it the blue colour which I've been using so far, just so that it's differentiated from the shot camera. Okay, so if we just spin around and look through the shot camera and we scrub around here, we can see the camera moving diagonally and slightly rotating around this particular scene. Okay, I've just locked the shot camera into the 3D view, so we can see that a little bit better against the camera frustum, and we can see something that if you've seen any of my earlier videos around projection types, then this will look relatively familiar. We can see that texturing is smearing. This is because the texture is being projected from this angle, so obviously around this side it's running out of coverage, and as the sphere turns around, obviously there isn't any coverage to fill this space, so what it's doing is it's just stretching out the material to fill the gaps in the UVs, and therefore we're getting this smearing effect. This would obviously equate to some severe degradation if this was actually part of a real matte painting. Okay, so let's assume that this matte painting contains information that needs to be projected onto more than one piece of geometry. Let's get to the nitty-gritty of what I'm trying to show here. So I'll make a copy of the Project 3D shader and the checkerboard. Just put them over here. I'll just look up my viewer to this checkmate node and just quickly whip through the colour swatches. Let's go with blue, and then I'm going to, what am I going to do? I will merge the new material over the older material. So I want to get my sphere, and I'm just going to bring both of these, this node graph down a little bit so that I can just pop my merge material node into that space, and then I'll just hold down Control and just drag out a dot node just to tidy that up. Okay. I won't bother with a new projection camera for now. I'll just hook this up to the same projection camera. So let's get into the scanline renderer. Okay, we need our card, which is our second node, connecting into the merge material. So we've got two pieces of geometry coming into this, and then we need to connect the card into the scanline renderer. And you'll see a slight problem there. If I just zoom in and show you this, then it's not going in, and that's because the scanline renderer will only take one feed. It will only take the feed from one input. Okay, through this this object scene input. So this is where these two nodes come in, and both of them will do exactly the same. The scene node is one that's come along a little bit more recently than the merge geo, but they'll both do the same thing. I'll just copy the scene node. They will both take potentially an infinite amount of inputs and output them as a single input for the scanline renderer. So this sits there as a conduit for the scanline renderer and basically brings a multitude of different 3D elements into the same stream, so that can then go to render via the scanline renderer and from the perspective of the shot camera. Okay, I'm just going to flip over into 3D because I just need to sort of organize this scene a little bit. So I'm just going to come into the default view. My card is laid flat. I don't actually want that. I want it to be stood up, and I just want to sort of push it back a little bit so that it's sort of sat behind, because that's the purpose of this shot camera, so it kind of reveals an area of the card from behind the sphere. Okay, so let's just flip into 2D view now, and we can see that basically our original scene has just gone blue, so it's exactly the same as it was, except it's blue. It's almost impossible to be able to see what's going on here, because we've got our sphere, and we can just about make that out, and we can see the checkerboard behind. So effectively, the texture is being projected onto both surfaces. Okay, so that's not really that helpful. So essentially, this projection, which is the blue checkerboard projection, serves absolutely no purpose when it's using the same camera, because all it's doing is it's just completely obscuring the grey material. So this needs to have its own projection. Now we already saw that the smearing was happening on the sphere as this went across. We saw this smearing happening, and that's because of a lack of coverage towards the end of the projection. So it makes sense to create a camera from the end of projection. So let's go with frame 90. So I'll copy that and paste it, and again I will rename it projection cam, and then append the name with the frame number, which is frame 90. Kill off the animation, say yes to the nag, and then give it the colour that I've been using for the projections, and use that to project in. Okay, so now we're starting to see something. not sure what we're seeing, but oh yeah, that reveals much. We can see if we just go over to the 2D view. Let me see why. Right, and I'll just pull this through. Okay, I won't cache the whole thing, I'll just pull it through. We can certainly see what's happening now, and in terms of the smearing, we can see that this is kind of patching the offending area on the sphere, as well as projecting onto the card behind it. So I guess from this, what we can see is that this model can prevent, or at least minimise, the amount of texture smearing, because it's obviously patching the area that had smeared out, because obviously the coverage at this side is actually seeing that surface of the sphere. So that's the positive consequence. The negative consequence, of course, if we look at this in the 3D viewport, the negative consequence is that we've got the doubling of textures. So, for example, if we kind of imagine that these are two buildings, sort of a rear building and a front building, then the texture from, let's say, building 1, let me go back into 2D to try and show this. So let's say the grey texture we want on our first building, our sphere, and the blue texture on our second building, our card. We can see that the texture from the sphere is doubling onto the card. We can see that at the top of the bomb here, and we can see that the texture from the card is doubling onto the sphere here. So I guess at this part of the experimentation that I did in preparation to record this video, this was kind of the point where I began to ask myself whether this approach had any place as part of a projection arsenal. So we're projecting onto the multiple surfaces, which ultimately was the objective. But if this was two buildings, then obviously we've got this issue with doubling. Now I could easily get around this by connecting each piece of the geometry directly to the Project 3D node. And by doing that now, what I'm doing is essentially I have one texture for one piece of geometry. So if I add a matte painting for this building, which is this, and then a matte painting for this building, which is this, then we can see now that these are being projected without any doubling back of one texture onto another. But of course we've revisited, or we've reintroduced the problem that our previous projection had temporarily resolved, which is this issue here with the smearing. However, we've already seen from work that we've done with previous demonstrations, we've already seen that we could use patching to overcome this problem. So just to give you a little bit of an explanation of how that might be resolved, what I can do is create a patch projection. So I'll get a Project 3D node over here using this projection camera, because this is the side of the projection where the smearing is taking place, and I'll project into my grey texture, and then I'll copy this merge material and then patch this over the top of this, and then take that feed into my sphere. And we can see now that I've got a patch projection taking place over this sphere. And if you recall from the previous demonstration of the patch projection, then all I would need to do at this stage then would be to introduce a roto node. O brings in the roto node, and then I would use the roto node, just have one just to come onto it, so that we're looking at just the 2D. I'd use the roto node there just to create my spline. I would then add an invert node and place that above the roto and tell it to invert just the alpha channel, and then pre-mult the alpha. So if we're looking at it at this stage now, then we've got our, if I look at the alpha channel there, we've got our alpha. So what we've now got, if I just go back to my scan now, is that we've got that patch projection there, sort of over the top of the of the original projection. And we can see how by using the spline we can extend that out to you know, to cover the space, and obviously use the feathering to blend that with the image behind it. But anyway, that's a bit of an aside. So I'm going directly into my original into this original arrangement here, where we've got one texture projecting onto one piece of geometry and the other texture projecting onto the other. So the fact that we can patch this smearing in itself suggests that there may be scenarios where it's actually better to have one projection, which is you know, which we had with this scenario. To have one projection like this, and then deal with the issue of doubling by way of or smearing, but deal with those separately using patching techniques. So there will be scenarios where it is legitimate, or it seems legitimate, that we could have this model where we're projecting onto multiple pieces of geometry from a you know, from a single matte painting. There may be other scenarios where the opposite is the case. So the two building scenario that I've been using earlier on in this demonstration suggests that that would be an example where it may well be better to cut up the scene into different objects and then project them separately. So I'm kind of recognising that there's a need to undertake a lot more research and testing in this area. Because I think that it's a decision that has to be taken on a shot-by-shot basis and determined to a large extent by how the camera moves in the scene and how this frames the geometry on which we're going to project. Anyway, I'll wrap up for now. I have to say that I've learnt a lot during my experimentation and preparation for recording this video, and I think I've also found it quite difficult to visualise the impact of these projection artifacts using checkerboards. I think in the future, when I do more work in this area, I'm going to conduct further testing by projecting real imagery, whether they be photographs or even actual matte paintings, onto geometry that I've modelled to align to the image that's being projected, and I think that that will give me a clearer understanding of these artifacts, and I'll be able to explain those with a little bit more clarity.